Here video plus audio has a bandwidth of 4.5 megahertz. This signal is sampled, quantized and binary coded to obtain PCM signal. A bar is asking determine the sampling rate if the signal is to be sampled at a rate of 2/9 above the Nyquist rate. And the B bar is asking if the samples are quantized into 1024 levels, determine the number of binary pulses required to encode each sample. And the C bar is asking determine the binary pulse rate bits per second of the binary coded signal. And the D part is asking find the minimum bandwidth required to transmit this PCM signal. Okay, so now let's look at the A part of this question. Okay, in the A part they have requested to find out the sampling rate, and also they have mentioned that this is to be sampled above the rate of 2/9 above the Nyquist rate. So let's look at this. So here the given bandwidth is 4.5 megahertz. The television signal bandwidth is 4.5 megahertz. According to Nyquist theorem, that frequency should be greater than or equal to the minimum frequency of the signal. Let's write that one down. According to the Nyquist theorem, the sampling frequency of the signal sampling frequency should be greater than or equal to the maximum frequency of the signal. Should be greater than or equal to the maximum frequency of the signal. And the Nyquist frequency is given by 2 times the signal frequency. Nyquist frequency is given by 2 times the signal frequency. Okay, so that is 2 times the given frequency for us is 4.5 megahertz. So we multiply that one by 2. That gives us 9 megahertz. That is Nyquist frequency. Now we have to find out what's the sampling rate. To find out, we have also provided this is sampled at the rate of 2/9 above the Nyquist rate. Let's use that and find out the sampling rate. And to find out the sampling rate, we use this equation. Sampling rate is equal to Nyquist frequency and that one plus whatever the rate we are sampling. In this case, that is 2/9. Okay, times the Nyquist frequency. Now the Nyquist frequency we found out is 9 megahertz. So let's plug that right here. 9 plus 2/9, and that one multiplied by 9 again. And 9 cancel. 9 plus 2, that's gonna give us 11, and this is in megahertz. Okay, that's the sampling rate. That's the A part of the question. We have to find the sampling rate. That's 11 megahertz. Now let's look at the B part of the question. The B part of the question is asking if the samples are quantized into 1024 levels, determine the number of binary pulses required to encode each sample. So level is equal to 2 power n. So here they have asked us to find out determine the number of binary pulses required to encode the sample. So we had to find out what's the n is here. So if you find that one out, that's the number of pulses required to encode each sample. So given the level 1024, we plug them one right here, and that is equal to 2 power n, and 2 power 10 is equal to 1024. Therefore n is equal to 10. Therefore we need 10 pulses. Thus the number of binary pulses required, to encode each sample are 10. Encode each sample are 10. Okay, that is B part. Now let's look at the C part of the question. The C part of the question is asking determine the binary pulse rate bits per second of the binary coded signal. Now binary pulse rate is given by n times the sampling rate. Okay. Here they have asked to find determine the binary pulse rate. That is what we are doing right here. And then n is 10, we found out from the previous question, and the sampling rate we found out in the first part of the question, that is 11 megahertz. So multiply this one by that. Mega is 10 to the power of 6, so let's put that one down. 10 times 11 times 10 to the power of 6, and this is in bits per second. Okay, so 110 times 10 to the power of 6 bits per second. Or you can also say 110 megabits per second, Mbps. Okay, that's the part. That's the answer for the C part. And then D part is asking find the minimum bandwidth required to transmit this PCM signal. Bandwidth minimum, we can use this formula to calculate that. N times sampling rate divided by 2. N is 10, we found out before, and then sampling rate is 11 megahertz. That's the A part of the question we found out, and then we divide them by 2. That gives us 110 divided by 2, 55 megahertz. Okay, and that is the minimum bandwidth required to transmit the PCM signal, this PCM signal. And that's it for this video. I hope you guys found this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.